Hello, class. Last week we took our soil test results and looked at what Lamont considers the optimal soil condition and went ahead and calculated how much fertilizer do we need to apply in order to get to that optimal soil condition that Lamont was describing, or that Lamont Guide was describing. But here's what we really know. We know that not all plants are going to use nutrients in the same way. Some are going to use more of others. For example, corn is going to use a lot of nitrogen, whereas something like cowpeas might use a lot of phosphorus. So if we're trying to produce a high yielding crop, something like corn, that's going to be taking a lot of nitrogen, and we go and calculate out that to find that optimal soil condition, we may be way under on the amount of nitrogen that we actually need to apply for the corn. So whenever we're actually calculating fertilizer, a lot of times we're going to be looking at what commodity are we actually going to be producing. So this week we're going to get a little more specific on things and look at actually how do we calculate for a specific commodity. So we're going to be using some resources here. We're going to be using some tables out of that instruction book that you would have used in order to actually follow the instructions to actually complete these tests. They're in your garden kit, in your soil testing kit. And then we're also going to be using the book, the Lamont Soil Handbook as well this week. And we're going to be generating some numbers. And we're going to be using some of that information in there. So what I would encourage you to do is read through that how to estimate fertilizer needs of specific crops on page 63, 64, and 65. On into actually page 66 of that garden or of that soil handbook, and then also go ahead and read that the importance of organic matter in high yield crops on page 66 and 67 of that same book. So we actually put some tables down here in the bottom of your document, some tables, important tables that we're going to need. So first off, this first table is converting our test results to pounds per acre from the instructions packet. So there in your soil test kit packet, there is actually those instructions on how to run that test. And at the end of each one of those tests, it says, all right, well, if you yield a low amount or a medium or a high amount of nitrogen, this is the estimated amount of nitrogen per acre in pounds per acre. Phosphorus, the same thing. Is say, for example, if your test results yield a medium phosphorus result, it's going to be somewhere between 50 and 100 pounds per acre. If you tested potassium, you got high amounts of potassium, it's probably going to be over 200 pounds to the acre of potassium. But whenever we went ahead and did our tests were actually in terms of very low, medium, high, and then high and very high. So what I actually did was I took this table right here of what was given in your instructions packet, and I expanded it to actually encompass all of those different possible results of nitrogen, phosphorus, and potash. So basically what I did is I took this table, kind of expanded it, and ran some averages. So this is actually the table that we are going to be using whenever we're going to be calculating how much or how many pounds per acre do we have of some of these nutrients already in the soil. So what you're also going to need to do is download this Lab 9 fertilizer need for specific plants test results or results document. We're going to be using that. We're going to be filling in that document as well. And if we continue on, well, let's go ahead and jump over here. So the first thing we're going to have to do is include the results from Lab 7 or from that soil testing lab. So I'm going to keep it the same with when I tested my backyard, the results that I've gotten there. So I had very low nitrogen. I actually had very high phosphorus. And then I had very low potassium. So now that I've gotten these are my test results from that test kit. Now I need to actually put it in how many pounds per acre of nutrients was there. So for some of you, you might have gotten a test kit that actually already gave you the pounds per acre of nutrients. And basically what you need to do here is just need to fill in what were those pounds per acre of those nutrients, if your test results didn't give you very low or very high or very low or medium or high, didn't give you those actual words, but it gave you the pounds, we're going to go ahead and just type in the pounds there. So for those that didn't do that don't have a test kit that said exactly what the pounds per acre were, we're going to take very low. We're going to come over to this table. We see that very low nitrogen. We're just going to assume that we have 0 pounds to the acre of nitrogen. Very high phosphorus. We're going to jump down here and we're going to find very high phosphorus of 150. So my backyard has about 150. We're going to estimate it to be about 150 pounds of phosphorus in my backyard. My potassium was very low. So we're going to jump up here. We're going to find very low of this potash. We often use potash or potassium interchangeably. And we had 40 pounds of potassium or of potash. So now that we've gotten that, now we actually get to look at which plants are we going to be using. Now we get to select a plant. So I want you to choose a plant, something that you might be interested in. So we have a list of plants here that we're going to actually choose from. We have alfalfa, apples, barley, cabbage, celery, corn, cotton, cowpeas, and you can look over the rest and it goes all the way down to the bottom. So we're going to pick one that we might want to go with. So I'm going to be assuming, maybe I want to plant Timothy in my yard. I want to go ahead and plant this crop, Timothy, in my backyard. Actually, yeah, let's go ahead and plant Timothy. So what I need to do is I'm going to go ahead and choose my plant. I'm going to type it in there, and I'm going to run my plant as Timothy. So now what I need to do is I need to figure out how much nitrogen, how much phosphorus, how much potassium are we actually going to be using for this plant. So that's what this table actually shows. This table is going to show that the plant, the acre yield, how much is it going to yield per acre, the amount of nitrogen, the amount of phosphorus, and the amount of potassium that it's going to generate, or it's going to need. So we're going to jump down here to Timothy, and I now know that I'm going to need 40 pounds per acre of available nutrients for Timothy. I'm going to say that again. I'm going to need, Timothy, 40 pounds of nitrogen, of available nitrogen, of usable nitrogen, or this plant is going to use 40 pounds of nitrogen per acre to yield 1.5 tons per acre. It's going to need 15 pounds per acre. It's going to use 15 pounds per acre of phosphorus to generate 1.5 tons per acre. So I'm going to go ahead and type that in right here, a 15. And then how much potassium am I going to need? For Timothy, I'm going to need 45 pounds of potassium. That plant is going to use 45 pounds of potassium. So we're going to type that in right here. Now, I kept trying to stress the aspect that it's going to use that much. So we might actually, if we look up here, we actually have 0 pounds of nitrogen, 150 pounds of nutrients of phosphorus that is available in the soil, and 40 pounds of potassium that is available in the soil. But the plant isn't going to use up all 150 pounds of that nitrogen, nor is it going to even be able to use up all 40 pounds of that potassium. You see, the percent available nutrient obtained by the crop during the season is the next table that we need to reference. And if we come right here, with the amount of nutrients that is available presented by the test, the amount that we tested for, out of all of the nitrogen that is available in the soil, so in this case 0, only 40% of it is going to be able to be used by that crop during that year 1, that first season. Same thing with phosphorus. We might have 150 pounds of phosphorus, but only 40 of it is going to be able to be used by that crop in year 1. You see, the soil isn't going to release all of the nutrients to use all 150 pounds of that phosphorus in year 1 because it's trying to keep some in reserve for next year. So it's only going to be able to release 40% of that is going to be able to be used by that crop. And then same thing with potassium. Only 40% of the available nutrients in that soil is actually going to be able to be used by that crop. So we're going to do some math real quick. So we went ahead and put up our calculator here, and what we need to figure out next is what is the pounds per acre of nutrients available in the soil for plant use. So we said that we have 0 pounds of nitrogen in the soil, and only 40% of it is available for the plant to actually use. These nutrients are available, but the plant is only going to use 40% of it. So how do we calculate that? We're going to take 0 amount of nitrogen in our soil times 0.4. Well, obviously that's going to give us 0. So we have 0 pounds per acre of nitrogen available in the soil for plant use. So what about phosphorus? We have 150 pounds per acre available, but the plant is only going to use 40%. So we're going to take that 150 times 0.4. So we actually have 60 pounds of phosphorus that is available in the soil for plant use. The plant is going to use, or is going to have the ability to use up 60 pounds. Well, what about potassium? Let's go ahead and figure it out for potassium. So we have 40 pounds of potassium in the soil that is available, but the plant is only going to use 40% of it. So really and truthfully, we only have 16 pounds of potassium in the soil that the plant is actually going to use in year 1. There's 40 pounds available, but the plant is only going to use 16 or have access to 16 pounds of that, or 40% of that. So next we need to figure out, now we know this is the amount that the plant is going to use. They're going to need 40 pounds, they're going to use 15 pounds, they're going to use 45 pounds, respectively, between nitrogen, phosphorus, and potassium. They're going to use 40 pounds of nitrogen, use 15 of phosphorus, use 45 of potassium. So what do we need to do next? We need to figure out, now that we know how much they're going to use, and we also know how much is available for that plant to use of nitrogen, phosphorus, and potassium. So if Timothy is going to use 40 pounds of nitrogen, and I have 0 available, then how many pounds of nitrogen do I need to add into the soil of usable nutrients? So we're going to take the 40 pounds that we need minus the amount that we have available, and we know that we're going to need to add 40 pounds of usable nutrients into that soil. We're going to have to add that 40 pounds in. So what do we need? What about phosphorus? We need 15 pounds. We have 60 pounds available. So we're going to take 15 minus that 60, and we come up with negative 45 right here. We actually need to add negative 45. Well, do you really need to add negative 45? No, we're not going to be taking phosphorus out of the soil. We're not going to be doing that. But because that's a negative number, we don't have to add any. We don't need to add any more usable nutrients to that soil. Well, what about potassium? So for potassium, we need 45, or the plant's going to use up 45. We have 16 pounds available for use of that potassium. So we take that 45 minus the 16, and we come up with, we're going to need to add 29 pounds of usable nutrients. Now that we know that we're going to have to add 40 pounds of nitrogen, 0 pounds of phosphorus, and 29 pounds of potassium. That's how much usable nutrients that we're going to that are going to need to be added. So can we just add 40 pounds of fertilizer with nitrogen, with basically 40 pounds of nitrogen, and call it a day? Well, not exactly, because the plant is not going to be able to use up all of the available nutrients out of that fertilizer. Matter of fact, with nitrogen, if you go and apply nitrogen, only 60% of the pounds of nitrogen being added is available to that plant in year 1. So really and truthfully, we might need to add 40 pounds, but we're actually going to have to add more than that to compensate for the fact that we're only going to use 60% of it. So how do we do that? How do we calculate that? What we're going to do is we're going to take the amount of usable nutrients that need to be added to the soil, and we're actually going to divide it by this percentage right here to get to that full amount. So we're going to take 40 divided by 0.6. And that's just a continuous number there. So it actually says that we're going to need to add about 66.67 pounds of nitrogen. Well, does that make sense? We're going to need to add, we need 40 pounds to be usable. So we're going to go ahead and add about 67. Let's go ahead and keep it whole numbers. 67 pounds of nitrogen. Only 60% of it's going to be available, so we're going to take that 67 times 0.6, and we come up with really close to the amount that we need. So we're actually going to add 67 pounds of nitrogen, assuming that only 60% of it's going to be available for use for this plant, and that's going to give us that 40 number that we need. What about phosphorus? Well, phosphorus, we didn't need any more nutrients. So how many pounds of nitrogen or of phosphorus are we going to need to add? Well, it's pretty simple. 0. We're not going to have to add any more phosphorus because we already have enough in the soil. We already have enough for that plant to have enough to grow and be successful. Well, what about potassium? How much potassium do we need to add? Well, with potassium, we need to do it the same way as we calculated the amount of nitrogen that we need to add. With potassium, we need to add 29 more pounds of usable nutrients. And out of the total amount that we add, only 50% of it is going to be usable, right here as it says right here on this table. So, how do we go about calculating that? Well, we're going to take that 29 divided by 0.5, and that's going to give us 58. So in order to grow, to be successful and grow 1.5 tons of Timothy on my property, tons per acre on my property, that tested low, high, and then very low, high, and very low on nitrogen, phosphorus, and potassium respectively, I really need to add 66.7 pounds per acre total of nitrogen. So that way there's there's 40 pounds of usable amount to compensate for the total amount, or that of the amount of usable nutrients that need to be added. Phosphorus, I don't need to add any. Potassium, I'm going to need to add 58 pounds of nitrogen or a phosphorus fertilizer. Sorry, I'm going to have to add 58 pounds of potassium fertilizer, a potash, to where, and assuming that only 50% of it's going to be used, to give me the 29 pounds of potassium that is going to be needed in order to produce that commodity. So essentially that's what you're going to need to do on this worksheet. First off, type in the results, convert that over using this table right here, the converting test results to pounds per acre, this expanded table, to figure out how much the pounds of nutrients available in the soil. Then we're going to choose a plant. You get to choose this plant. I want you to think of a plant that might actually be used on your property or something that you might be interested in. A couple of them that you might look at if you're in Wyoming is maybe alfalfa or corn or maybe barley, and maybe timothy or wheat, maybe even tomatoes. If you're in other places, maybe find something like peanuts or tomatoes. It just kind of depends on what you might be interested in actually growing on your property. And then you're going to take, just like we did, if we said if we're going to produce timothy, we're going to need 40, 15, and 45 of nitrogen, phosphorus, and potassium. That's how much that plant is going to use. So then we figure out how much of the available nutrients is actually there for the plant to use using this table down here. So we figured out, in my case, it was 0, 60, 16. Then we're going to compare that to the amount that is needed, that the plant needs to use. We're going to compare that to the amount that's available in the soil for plant use. And then we're going to also compare that to, then we're going to figure out how much do we need to add of usable nutrients from the fertilizer. And we're going to calculate that right there. Then we're going to go ahead and calculate exactly how many pounds do we need to add of nitrogen, phosphorus, and potassium. Now, I want you to keep a couple of things in mind, especially as we look at some of the legumes. And I wrote right here, legumes often are nitrogen fixators, which means they're actually going to be putting nitrogen back in the soil. So a legume, something like sweet clover or red clover, might be actually using a lot of nitrogen. We see that red clover is going to actually use 80 pounds of nitrogen, but it's also a nitrogen fixator. So you may not actually need to apply that full 80 pounds into the soil. It may use that much. It's going to use that much, but you may not even actually need to add that much because it's actually going to be doing part of the process for you. So that's one thing to keep in mind. Another thing to keep in mind is if you do this lab using corn, you're going to see that corn is a high-yielding commodity. And we see right there that corn is actually needing 240 pounds of nitrogen. We're going to need this much, 100 pounds of phosphorus, 240 pounds of potassium. So we're actually, on cornfields, we actually often add a lot of fertilizer because it is a high-yielding commodity. And kind of a rule of thumb is actually oftentimes you're going to add 1 pound of nitrogen per acre per bushel that you're looking to produce. So that's kind of an old rule of thumb. Well, if you go ahead and plug all of that in to this worksheet, we're going to see that we're way over that. In some cases, we might be needing to add 340 pounds of fertilizer, almost double, or 340 pounds of nitrogen for 180 pound or 180 bushel per acre yield, which is almost double what that rule of thumb that I just mentioned is. Well, that's why I would encourage you to go ahead and read how the organic matter influences nitrogen use. And that's in that that next section of that Lamont soil handbook. And look at how much something like organic matter is going to influence fertilizer use as well. Because if you're in an area with a lot of organic matter, you may actually not need to apply as much as we're talking about in here, because organic matter is going to apply it in there. So go ahead and make sure that you read through that part and kind of become well versed in that as well, or understand how organic matter impacts truly how much fertilizer do we need to add. If y'all have any questions on this lab, please don't hesitate to get a hold of me. And good luck on this assignment. Good luck on this lab.